Solving chemical problems. So we're going to be solving a lot of problems in Chem 1A, and many of them will take the form of word problems. Many of these problems can be solved or approached as a unit conversion problem, just a matter of converting units from one unit to another. Some of them will also require using an equation, or there may be some that you only do with an equation. So first we're going to talk about the units. So dimensional analysis is a technique where we solve problems using units as a guide. So in dimensional analysis, the units are going to lead us, the units are going to tell us what to do. We don't need to remember a formula, we just need to look at the units. I learned this in high school physics as a junior, and it's probably the most valuable thing I learned in all of high school was dimensional analysis. My teacher showed us how you could fudge your way through much of physics if you had a good grasp of units. Just put the numbers they give you together so the units work out. And most of the time, it's going to be okay. So, very important, units should always be included in calculations. Always, always. I know it's tedious, but repeating the course because you failed is also tedious, right? That's way more tedious. It's really important to write your units down. Units act a lot like algebra variables, x's and y's, etc. You can multiply them, you can divide them, they can cancel out. They sit there like the letters in algebra equations, okay? So, what is often called a unit equation is just a statement of two equivalent quantities. Here's an example. 2.54 centimeters is equal to 1 inch. These are two different ways of describing the same length. You have a piece of, I don't know, wood or a short pencil. And, okay, it's 1 inch long. If you measure it with a metric ruler, it's 2.54 centimeters long. Two ways of describing the same thing. They are equal, okay? From this equality, we can make it conversion factors. A conversion factor, we can actually make two. So conversion factors are usually written as fractions, and we're going to put the unit that we want to get to on top and the one we want to get rid of on the bottom. And I'll demonstrate that more in a future slide, but let's just look at how we come up with these conversion factors. So we are okay with this, right? 2.54 centimeters is equal to 1 inch. Everybody okay with that? So I can turn this into a fraction. So let's divide both sides by 1 inch. Why? Because I feel like it. So with a mathematical equation, if you do the same thing to both sides, it's still equal. A math equation is a little bit like a balanced teeter-totter. And if you put the same amount of stuff on both sides, it's still balanced. Okay? So if I do the same thing to both sides, it's still equal. What is 1 inch divided by 1 inch? It's 1. Anything divided by itself is 1. So we say those cancel out. Well, I'm going to go a step further and just erase them. They canceled out. They are equal to 1. That means that 2.54 centimeters divided by 1 inch is equal to 1. If I multiply something by 1, does it change the value? No. So I can multiply a number of inches by this, and it's not going to change the value of the measurement. The number will change, and the units will change, but it's just a different way of describing the same thing. We can also take this and turn it upside down and say that there's 1 inch per 2.54 centimeters. That is also equal to 1. So conversion factors are fractions where what's on the top is equal to what's on the bottom. They've got different numbers and different units on the top and the bottom, but they're equal to each other. Any questions? So most conversion problems are going to take this form. You're going to start with something that's been given to you. You're going to apply one or more conversion factors, and then you're going to get what they're asking you for. Another way to state that is we take the given unit, and we're going to multiply by a conversion factor where the desired unit is on top and the given unit is on bottom, and that will give us our desired unit. So we're going to do a very simple example here. How many centimeters are 12 inches? Are in 12 inches? So I'm given this quantity, 12 inches. I want to find out how many centimeters. So I'm going to multiply by a conversion factor where my desired unit is on the top. I desire centimeters. And the given unit is going to be in the denominator. So I've got 12 inches multiplied by some number of centimeters and divided by some number of inches. When I take that unit, which is like a variable, inch divided by inch, we say those cancel out, right? So poof, gone. The unit I'm left with is centimeters, okay? But a centimeter is not equal to an inch. These need to be equal. So it's 2.54 centimeters to 1 inch. That's one of the two factors we got from that equality. So then we do the math. 12 inches times 2.54 centimeters per inch, and I get 30.48 centimeters. Is that my final answer? Always have to consider significant figures. Well, how many significant figures does 12 inches have? 2. You might be tempted to say it's exact. No, 12 inches is a measured thing. We're not saying that a foot is 12 inches. We're just saying we have something that's 12 inches. That's measured. It's not exact. 2 significant figures. How many significant figures in this relationship? It's more than 3. This one is exact, okay, because they redefined the inch. So this is that one you have to remember. This one's exact. So how do we deal with that? Well, we don't have to deal with it. If you have an exact conversion factor, you don't even have to look at that one. It's not going to affect your number of significant figures. So here I started with 2. I need to end with 2. So right there. So I look at the 4, the next digit, and I say, well, I need to round down. So 30 centimeters. Is that good? No. Because if I write 30 centimeters, someone else is going to look at that and say, oh, that only has one significant figure. How can I show that this has 2 significant figures? I could put a decimal point here. Oops, I think I can. There we go. That's okay. It's better to put it in scientific notation because then it's very clear. So in scientific notation, we would write 3.0 times 10 to the 1 centimeter. That's the best answer. Any questions? So, general problem-solving strategies. I know that many chemistry students struggle with problem solving, and in Chem 1A, it's a big deal. In Chem 3A, we teach you specific types of problems to solve, and you can get by just learning how to do those problems. In Chem 1A, I am going to give you a problem on the exam that is different than any problem that has been on the worksheets for the homework. It might be working something backwards that we've done forwards a lot. It might be taking 2 concepts and putting them together, but you're going to have to do some critical thinking. So, general problem solving. Identify the starting point. Identify the end point, and then figure out a way to get there. So this is like going to a mall. This summer I went to the Stanford Mall. Really cool outdoor mall. Very confusing though. So, like, I'm supposed to meet somebody at Starbucks and I can't figure out where Starbucks is. So you find one of those kiosks with the map on it, right? It's like, oh, wow, look at all of that. it's not helpful until you figure out where you are on the map. That's why they often have that red circle, you are here, right? So that's identify the starting point. What am I starting from? You can't successfully navigate anywhere if you don't know where you are. So where are you? And then figure out where am I going? So then I had to find Starbucks on the map. And then I figure out, okay, how am I going to get there? Am I going to go up here and take a left, or should I go over there and take a right? What would be the best way? As with many things, there are often multiple ways to get from that starting point to the ending point. Which way you take depends on the information that you have available and how your mind works. And people's minds work differently. So another, excuse me, choked up about dimensional analysis. Another way to approach this is to think about sort, strategize, solve, and check. So sorting means, you read through the problem, you pull the numbers out, you sort them. Identify them. We did that with that density problem. Then you strategize. Okay, what do I need to do with this to get the answer? Then you go ahead and you do that. You do the solving. And then check your answer. How do you do that? Well, look at it and think about it. Is it reasonable? Sometimes you can't tell if it's reasonable, but sometimes it's pretty obvious. Sometimes it comes out unreasonable because you you did something dumb. We all do dumb things. That doesn't mean we're dumb, but I do stupid things at least once a day, but I'm not a stupid person. Okay, it's okay to do stupid things. Just try to learn from those mistakes and not do them again. So what if you were trying to calculate the average family size in California, and you did the calculation and you came up with 0.04 people? Could that be the average family size? 0.04 people in a family? No. What is 4/100ths of a person?
Dead person.
A dead person? Is that like somebody's arm? Or that's gross. What? It doesn't make any sense at all, right? I suppose you could argue that one person could be their own family, right? But generally we think of a family as being more than one person. An average doesn't necessarily mean you're going to end up with whole numbers of people, right? But you can't have less than one person, right? So obviously something went wrong. So sometimes you can look at the answer, step back, use some common sense, and say, no, that couldn't possibly work. There's a problem in your worksheet at the very end. It's a fun one where you have to calculate the mass of the ice covering the continent of Antarctica. So a student yesterday came to show me her result, and she came up with 629 grams. Is that reasonable? No, it's not. I could carry 629 grams. It's like maybe 2 pounds or so. It's not much, right? I think it should be bigger than that. It's way, way bigger than that. And what happened, she showed her work, but she had no units in her work. And so she took the numbers and was doing the right thing with the numbers. But some of them were miles, and some were feet, and there were cubic centimeters, and there were grams, and she ignored all the conversions, and so she came up with this crazy answer. And she came up and showed it to me because she thought that was kind of small, right? And she's like, what did I do wrong? But she can look at the answer and, get an idea of whether it's right or not. So let's practice here. So convert 288 centimeters to yards. We're going to start out with some that are very simple, very few words. It is important to learn how to write these out, showing your work and showing the units with these simple ones, so that when we get to the more complicated ones, you can do that. So, where are we starting from in this problem? 288 centimeters, right? That's got to be the starting point because it's the only number in there. So centimeters is what we're starting with. What do they ask us to find? Yards. So I'm going to put that over here. Yards. So this is where I am. This is where I'm going. I need to figure out how to get there. I call that the path, right? How am I going to go? Well, do I know how many centimeters are in a yard? Not off the top of my head, I don't. I could go look it up, but that's not the point of this exercise. What can I convert centimeters into? Inches, right? Because see, this is an English unit, and that's a metric unit. And so we have to get from metric to English somewhere, and I know that centimeter to inches. So I know I can go centimeters to inches, because I know that one. Could I go inches to yards? Yeah. A yard is 36 inches. I know that. Now, maybe you don't know that, right? Hopefully you know that a foot is 12 inches and a yard is 3 feet, right? So you could go from inches to feet to yards. I'm just going to go directly to yards. There's my path. This is getting the path. That's the hardest part. That's the key to solving the problem. Once you have that, you can just follow the path and you'll get there. So how do we do that? Well, you take your starting value, 288 centimeters. I'm going to look at my path and say, how many arrows do I have? I have 2 arrows. That means I need 2 conversion factors. So 288 centimeters times a fraction times a fraction. Okay, 2 arrows, 2 fractions. The path is centimeters to inches to yards. This reminds me of Dora the Explorer, right? Who do you ask when you don't know which way to go? The map, right? And the map will come. Well, if you want to get to yards, first you need to start at centimeters, and then you need to go to inches, and then you need to go to yards. And then they would chant, centimeters to inches to yards, except, it was the snowy forest or something like that. And the troll bridge, that happened a lot. Centimeters to inches to yards. So that's what goes on top here. Centimeters to inches to yards. We could do that, right? We're just copying the path down into our equation. Okay? Now, I want centimeters to go away. I don't want them at the end. So I want to divide by centimeters. So I'm going to divide by centimeters in the next fraction so that centimeters are going to cancel out. And then I'm going to take inches. I need inches to go away, and I'm going to divide by inches in the next fraction. So the inches cancel out. And now my units are good, right? I have left yards. That's the only one, and that's what I was trying to get to. So this is looking at the units. It's the units telling us how to do the problem. Okay? Now I need to put the numbers in there, right? And you may or may not need to actually write down the conversions, those unit equations. So what we're using here is 2.54 centimeters is equal to 1 inch, and 36 inches is equal to 1 yard. Those are the 2 that we're using. You don't necessarily have to write those down. So inches and centimeters, this is the relationship. The number has to stay with its unit. So 2.54 goes with centimeters. That happens to be on the bottom in this one. So 2.54 centimeters is equal to 1 inch. In the next factor, I have yards and inches. 1 yard is 36 inches. Everybody okay with that? So this is the equation set up, and this is the minimum you should have down for showing your work. You don't have to write the unit equations. You don't have to write the path. If you're having trouble, you should write the path. If you're good with it, you don't have to write the path. But the minimum is writing it out like this. And if you want to use the train tracks method where you've just got vertical lines instead of the time signs, I'm fine with that. But I want to see the units canceling out. So on the calculator, this could be entered different ways, but I want you to do it this way, because in the long run it's going to be easier. You take the first one, 2.88, and you multiply by the number on the top, you divide by the number on the bottom. You multiply by the top, you divide by the bottom, you just go across like that. You don't have to write down any intermediate values. You don't have to go back and forth. You're not going to skip anybody. Now, obviously, multiplying by 1 isn't going to change anything. So do you have to multiply by 1? No. But some people say there's a 1 there and I'm going to multiply by 1. You go right ahead and do that. That is absolutely fine. Okay? So what I'm going to do is I'm going to do 288. I understand, I think times 1 in my head, but I don't actually do that. And then divide by 2.54. Times 1, divide by 36, and I press equals. Now, when we're writing the number down, this is a whole mess of digits. I don't want to write all of them down. So I'm going to think ahead a little bit. I'm going to think about sig figs. This is an exact conversion, and this is also exact because it's within the English system. So my number of sig figs in the answer will be dependent on the number in the beginning. So here I have 3 significant figures. So that means in my answer I'm going to have 3 significant figures. So I'm going to write down the first 3 digits, 3.14. I'm going to underline the third one as a little note to myself. That's the uncertain digit. And then I'm going to write down just the next 2 digits. Not all of them, just 2. So the next one's 9 and then a 6. And then the unit would be yards. That's not my final answer. But the reason that I want to write down those 2 extras is, what if I go on in the worksheet and I realize I have to take this number, this result, and use it in another calculation? I don't want to use a rounded one because that could introduce rounding errors. So then if I had rounded this directly, I would have to go back and do the calculation again. The other thing is sometimes you realize, oh shoot, I rounded that wrong. By putting a couple extra digits there, you can come back and fix your rounding problem later. So I really recommend that you do that. If you want to write down the 06299, go for it. So now I'm going to look at this number. I'm keeping the 4. My decider is the 9, which tells me I'm rounding up. And so my answer is 3.15 yards. Any questions? I'm really hoping that you can follow this simple one and then do some practice and get it firmly in your brain so that when we get to some things that make less sense, that it'll not be as difficult. Any questions? Yes?
Understanding why it's 3.1 instead of 3.15?
Because of the 36? Okay, that's a good question. Why isn't it 2 sig figs because of the 36? That's because 36 inches equals 1 yard. That is by definition. So that's within the English system of measurement. A yard is exactly 36 inches. A yard is exactly 3 feet. A foot is exactly 12 inches. And so those are defined relationships.
So for the sake of argument, it looks like 36.2, that'd be 360.
Yes. Now, kind of as, sort of a hack on sig figs, especially on an exam where you're just like, a lot of times students just kind of lose their minds, right? You just can't even write your own name, and you forget the rules of sig figs. So how could you guess and get the right one? Well, a lot of times, the number that's given is the thing that limits the number of significant figures in the answer. There's a reason for that, but we don't need to go into it. So most of the time, what you start with is what you end up with in terms of numbers of significant figures for unit conversions. The other thing we'll find is that 3 or 4 is a common number of sig figs. But any other questions? And see, if we forgot that this was exact and we rounded it to the 1, but we wrote down 2 extra digits and then came back and realized, oh, that's exact, I should have had 3. We've got a little cushion there. We don't actually have to do the calculation over again. We could just change the rounding. Okay, convert 9,255 cubic centimeters to gallons. Well, let's see. Write down what we're starting with. 9,255 cubic centimeters. And then we're trying to get to gallons. Anybody just off the top of their head know how many cubic centimeters are in a gallon? I don't. Oh, they did this one on the homework? Cool. That's unfortunate. This one's from the book. Why would they put the homework? Anyway. So we have to figure out how to get from one to the other. And sometimes this involves just starting at the beginning and going to the end, but sometimes you start at the beginning and you're like, I don't know. So sometimes you have to start at the end and kind of work backwards, and then maybe go to the beginning, and you kind of work in from both ends until you meet in the middle. And there's more than one correct way to do it. There's more than one path. I live in Reedley, I drive to Fresno. There's more than one way you can get there efficiently. But I have my favorite way because I like it better, right? And so one person may like one path better than another person likes it. Okay, let's see if this is going to work. Nah, okay. I'm experimenting with animations. No, that doesn't work very well. Okay. Pardon that. Okay, I'm just going to write this down again. We need some extra information here. So if we go to the table of unit conversions, we can find this one, relating liters and gallons. Because what we have here is a metric unit of volume, and here we have an English unit of volume. So we're going to need a conversion factor that relates the two somewhere. So because I found this, I know that if I got to liters, I could get to gallons using this. So what I need right before gallons is liters. So I'm working backwards. And then here, cubic centimeters to liters. Well, the often overlooked conversion, 1 cubic centimeter equals 1 milliliter. So I could use that and get to milliliters. Now I'm closer, and milliliters to liters just involves using metric prefixes. So that's one way to get there. Any questions? Now you could go to the internet, or I have a cool calculator that would probably do this for me too, and find a direct conversion between cubic centimeters and gallons. You can't do that on an exam. And that's going to take some time. It's not as simple as it sounds. When you understand how to do this, all you need is one relationship from the table in your textbook. That has pretty much everything you're going to need. And then you can figure the rest out. So I've got my path. Now I'm going to write my equation. 9,255 cubic centimeters. This one has 3 arrows, so 3 conversion factors. Cubic centimeters to milliliters to liters to gallon. That's what Dora's chanting as she's going through her little world. So I take these units from my path and I write them as the numerator in all of my things here. Then I take the first unit and I make it the denominator in the second conversion factor. those cancel out. And this is milliliters, those cancel, and these cancel. Okay? Units first. The units tell me where to put the numbers. Now I need to put numbers in each of these, and you can do them in whatever order you want. This one, where's my pointer? This one looks the simplest, right? 1 cubic centimeter is the same as 1 milliliter. So that one's pretty easy. This is just 1/1. This last one, gallons and liters, that's this one I pulled out of that table. So there's 1 liter. So 1 liter and 3.785 gallons. Okay? I am taking one side goes on the bottom, the other side goes on the top. You can't mix and match numbers and units. It doesn't work. This middle one, I've got liters and milliliters. I don't need to go look this up anywhere. I need to rack my brain for the information that you're working on memorizing for that quiz on Tuesday, and find that milli stands for 10 to the minus 3. So here I've got milli on the bottom. I've got 1 milliliter on the bottom. On the top, I'm going to write what milli means. 10 times 10 to the minus 3. Yeah, question?
It's 3.785 liters in 1 gallon.
Did I write that backwards? Dang. Yeah. Oh, shoot. Thank you. Thank you for telling me, because otherwise we just get so confused. Okay. I can fix this. Or not that one, this one. So we'll do this. See, apparently I can't even copy that down correctly. How sad is that? I'd like to say I put that there to see if anybody was paying attention. Unfortunately, that is not the case. Okay, so we got to get this out of there. Okay, so it's 1 gallon and 3.785 liters. The metric conversion in here is one that some students just get backwards in their head. The prefix is on one side of the line. The 10 to the something is on the other side of the line. They are never, ever together. That's what I'm presenting in lecture. Okay? You use the 10 to the something from that table, and you don't put 10 to the something with the prefix. They're always on opposite sides of the fraction line or an equal sign. So as I'm going across and multiplying and dividing, this is a number in scientific notation. And so you're going to want to use the EE or the EXP button on your calculator. So I'm going to go 9255 times 1 divided by 1 times 1 EE minus 3 divided by 1 times 1 divided by 3.785. And I start writing down numbers, and I'm like, oh, I don't want to write them all. How many sig figs is my answer going to end up with? I'm hearing little whispers of 4. 4? 4. So the starting number was 4. That's exact. That's exact. This one's not exact, because it's between metric and English. So this is 4 sig figs, and so I'm going to end up with 4. So there's my 4. Underline that one, and write down the next 2 digits, and then the unit is gallons. And then I'm going to go back and round it. It's 2.445 gallons. Any questions? Sometimes we need to convert squared or cubed units. And when we do that, we have to square or cube the numbers involved as well as the unit. So I know that 2.54 centimeters is equal to 1 inch. I need a relationship between square inches and square centimeters. I can't say that 1 square inch is equal to 2.54 square inches. Let me show you why. So we've got a square, and we need to find the area, right? This side is 1 inch long, and this side is 1 inch long. So the area then is 1 inch times 1 inch, which is 1 inch squared. Simple enough. What if we measure the same square with a centimeter ruler? This side is 2.54 centimeters long, and this side is 2.54 centimeters long. And then I calculate the area. That would be 2.54 centimeters times 2.54 centimeters, which equals 6.45 square centimeters. It's not 2.54 square centimeters because it's the length times the width. The numbers get squared as well. Here's another way to look at it. So I can take this unit equation and square both sides, because if I do the same thing to both sides, it's still equal. So I'm squaring this and I'm squaring that. And then I'm going to distribute this into the pieces inside, and I get 2.54 squared and centimeters squared. And over here I get 1 squared and centimeters squared. Inches squared. And then I'm going to do the math. 2.54 squared is 6.45. I carry down centimeters squared. 1 squared is just 1. And I carry down inches squared. And so 6.45 square centimeters is equal to 1 square inch. That's the same thing I found over here. Does that make any sense? So how many cubic centimeters are there in 2.11 cubic yards? Well, we are starting with 2.11 cubic yards. There's only one number, that's where we're starting. And we're trying to get to cubic centimeters. In that table, there aren't any cubic this to cubic that. They're not in there. We need relationships with just the length, and then we make our own. So do I know the relationship between centimeters and yards? Not off the top of my head. We did a problem kind of like this before, right? We went through inches. So I could do inches in here, cubic inches, so I could go cubic yards to cubic inches and then to cubic centimeters. Because I can convert yards to inches to centimeters. So 2.11 cubic yards. 2 arrows, 2 fractions. Cubic inches, cubic centimeters. Just following my path. Put cubic yards down here, cubic inches down here. Units cancel out. Everything's looking lovely. I need a relationship between inches and yards. There are 36 inches in 1 yard. 36 to 1. But the unit is cubed. The numbers also have to be cubed. So that's 36 cubed and 1 cubed. I think one of the reasons people have some trouble with this is because 1 cubed is 1, and so it doesn't look like anything happened to the 1. And then here, the centimeters to the inches. It's that same number, 2.54 to 1, but I need to cube the numbers. So if the unit's cubed, you cube the numbers in the conversion factor. If the unit is squared, you square the number in the conversion factor. It's great to understand why, but if you can just remember what to do, that's plenty good enough. So there are different ways to put this into your calculator. You need to figure out how yours works. 36 cubed means 36 times 36 times 36. So you can just multiply by it 3 times.
Do we cube the 2.11?
Good question. Do we cube the 2.11 because it's yards cubed? No. So when we're looking at a conversion factor, we have to cube the numbers. But if they wanted this number cubed, they would have either put an exponent on it or just done the math. So the starting number, don't mess with it. Just leave it alone. So 2.11 times 36 cubed, 36 raised to the 3rd power, times 2.54 cubed equals ginormous number. 1613210. I need to get to the decimal point, and then there's only 2 digits after that. I might as well write those down too. Should we be getting a giant number? How big is a cubic centimeter? It's little. It's like maybe the end of your thumb, right? It's very small. And a cubic yard is a yard on each side. So here's my meter stick. So it's a cube. That's pretty big, right? That's going to have a lot of those little tiny centimeters cubed in it. So yeah, we should expect a big number. How many sig figs should this number have? 3. We started with 3. Exact conversion, exact conversion. So 161, there's the 3rd digit. That's in the 10,000s place. We need to be careful. So we look at the next digit, the decider, and we're going to be rounding down. We're going to keep it a 1. So we can go 161, but then we have to replace the rest of those digits to the decimal point with zeros. So the 3 becomes a 0, the 2 becomes a 0, the 1 becomes a 0, and the 0 is a 0. And I don't write the decimal point. So that's one way to do it. I think it's better to put it in scientific notation. 1.61, there's my 3 sig figs, times 10 to the something. I'm moving the decimal point. I don't start at the end of the number. I start at the decimal point. So I move the decimal point 1, 2, 3, 4, 5, 6 places. So the exponents, yeah. So the exponent is 6. And is it a big number or a small number? It's a big number. I feel positive about big paychecks, so it's a positive 6 cubic centimeters. Any questions? This is the best answer. That one's okay. Here's another one with more of a story. A vineyard has 145 acres of Chardonnay grapes. A particular soil supplement requires 5.50 grams for every square meter of vineyard. How many kilograms of the soil supplement are required for the entire vineyard? And we're given a factor here. 1 square kilometer equals 247 acres. Now that's practical, right? You need to put a supplement on your field and you've got to know how much. What do? I read the problem. I'm going to pull the numbers out. I'm just going to write them down. So the first one is 145 acres. And then we've got 5.50 grams for every square meter. Would that be the same as 5.50 grams per square meter? Yeah. So let's write this as a fraction. 5.50 grams per square meter. When I write this as a vertical fraction, it helps me to recognize that that might be a conversion factor. So conversion factors can be things other than unit relationships that you find in a table. And then I've got this guy. I'm not going to write that down because it's pretty good right there. So I've got these two numbers. I'm not exactly sure necessarily which one I'm starting with, but I also need to identify where am I going. What do I need to find? Kilograms. So I need kilograms. Well, I got two numbers here. I mean, this one's obviously just going to be a conversion factor. But I have these two numbers, and sometimes we have a hard time deciding, well, which one am I supposed to start with? Well, one of these could be a conversion factor. This one could be a conversion factor. This one can't. This is just an area. So the one with the simple unit is usually the one you're going to start with. This is a derived unit. That's usually going to be a conversion factor. So we're going to start with acres. We're going to start with acres, and we need to get to kilograms somehow. Well, what kind of relationships do I know involving acres? The one they gave me here, right? So I'm given a relationship between square kilometers and acres. So I could convert my acres into square kilometers. Well, that's nice. I don't know where to go from there. I want to end up with kilograms, and I'm looking at this and I'm thinking, oh, hey, that's got grams in it, right? So if I got to grams, I can go to kilograms. This is going to give me a relationship between grams and square meters. Could I go from square kilometers to square meters? Yeah, I should be able to do that. So that's going to be my path. That's the hard part. You are all intellectually capable of doing that. So now I've got my path, I can start writing my equation. 1, 2, 3, 4. 4 arrows, 4 factors. Copy the units down. Acres to square kilometers, to square meters, to grams, to kilograms. Getting this was the hard part. Now we just copy stuff down and put stuff in. Acres needs to go away, so I divide by acres. Those cancel out. Kilometers squared need to go away, so those cancel out. I'm going to put meters squared down here, so those cancel out. I'm going to put grams down here, so the grams cancel out. All my units are ready. The units tell me where to put my numbers. Some of the numbers are on the screen right now. Some of the numbers I need to bring in from my knowledge of metric prefixes. So this one, 1 square kilometer, 247 acres. So I'm going to use these numbers in the fraction that has both of those units in it. That's this first one, square kilometers and acres. So 1 square kilometer is 247 acres. I'm going to need this guy somewhere. This relates grams and square meters. So that's this one right here. There's grams and square meters. So 5.50 is with grams. There isn't a number with square meters. It's 1. Per square meter, we mean per 1 square meter. You don't have to write the 1 there, but some people find that comforting. It's fine. I'm going to ignore the squared one for, I like to just do the easier ones first. right? And that one's icky, so I'm going to do this one. I've got kilograms and grams. I've got a metric prefix on the top and no metric prefix on the bottom. So kilo, the K, stands for 10 to the third. So 1 kilogram is 1 times 10 to the third grams. Now I have to deal with the squared thing. It's actually not that bad. Put numbers in that relate meters and kilometers. Well, I've got a kilometer on the bottom, and so I need 10 to the third on the top, right? So 1 times 10 to the third and 1 for the kilometers. That's without the square. Then I have to square the numbers. So I'm going to take this. I should have left more room for this. I'm going to square that number. I'm going to square this number. The number that we stick in here for meters squared to kilometers squared, or vice versa, that's the same number as for meters and kilometers, but I have to remember to square it because the unit's squared. Okay, so now we multiply and divide. 145 times 1 divided by 247 times 1 EE3 squared times 5.5 divided by 1 times 1 divided by 1 EE3 equals. And I'm looking back and I'm seeing a lot of things with 3 significant figures. 3, 2, 2. I want to make sure I write down 2 extras, 0.7 kilograms. This has 3 sig figs. This one has 3 sig figs. This has 3 sig figs. These metric ones are exact. So my answer is going to have 3 significant figures. Did you get that answer, 3,000 something? I did divide by 1,000.
3,228.
Mm-hmm. You didn't get that?
0.7, I got that.
You got that? Good. So this, I actually don't recommend simplifying the equation, but we see that we have 1 times 10 to the third squared in the numerator and 1 times 10 to the third by itself down here. So in essence, this one is canceling one of those. It's better, I think, to develop a relationship with your calculator and just put it all in. One thing I like about the 36X Pro is that I can go back and look at what I punched in. Otherwise, if you come up with the wrong answer, you may not notice. That's why, especially like on a test where you really are invested in getting the correct answer, put that in twice on your calculator. If you get the same answer the second time, that's a good sign. If you get a different answer, then you need to do the calculation a third time and go for best 2 out of 3. Because you're probably making some random mistake, like missing the 5 or something, and you won't do that again. So how do I round this? Scientific notation would be great. The 2 rounds up to a 3, and I can replace that 8 with a 0, so I could do that. It's better to put 3.23 times 10 to the third kilograms. Is that a reasonable number? 3,000 kilograms. Yes?
Why did you square the 1 times 10?
That's a good question. Why did I square this? I squared that because the unit meter is squared and the unit kilometer is squared. So the relationship between those, 1 kilometer equals 1 times 10 to the third meters. If I square those, I end up squaring the numbers as well, and that's really important. Yeah. Any other questions? It's a big number, But this is 145 acres, and 5 grams for every square meter. That's not very big. So, yeah, it's not crazy. Okay, here's another one of the story. Backpackers often use canisters of white gas to fuel a cooking stove's burner if one canister contains 1.45 liters of white gas and the density of the gas is 0.710 grams per cubic centimeter. What is the mass of the fuel in kilograms? Read the problem, pull out the numbers. 1.45 liters and 0.710 grams. This is written as a horizontal fraction because it's easier to type into the computer. But you're not typing when you're doing these problems on paper. So make it a vertical fraction so that you are more aware that that is a fraction. Those are the numbers given. What am I asked to find? Kilograms. So here's the question word, what? What's the mass in kilograms? So I need to get from liters to kilograms. Why am I not going to start with this one? That's a conversion factor. I'm not going to be able to use this as a conversion factor. So I'm going to start with this one. So I've got liters and I need to get to kilograms. And I'm probably going to need to use this in here. We are using density as a conversion factor. We could use the density equation, but it is my goal to convince you that using it as a conversion factor is actually much easier. So we're just going to think of this in terms of units. So this has grams and cubic centimeters in it. Here I've got kilograms. So the unit before that might be grams, because I know this relationship. And if I've got this thing here, I could use that to go from cubic centimeters to grams. And then I need to jump from liters to cubic centimeters. And this is where it's good to remember, whoops, I didn't want a 1 there, that I can convert milliliters to cubic centimeters because they're actually the same thing. And then I can go liters to milliliters. So there's my path, 4 arrows. 1.54 liters times in a line, times in a line, times in a line, times in a line. I know this is getting tedious. I did all of this yesterday. I am boring myself. Except when I make fun of myself and I find that amusing. Taking these units and copying them down. Liters come down here. Milliliters come down there. Cubic centimeters and grams. Once we get the path, it's pretty much the same idea after that every time. So now I need numbers. I've got all my units in place. I'm looking at this one, kilograms and grams. Kilos on top. I'm going to write what kilo means on the bottom. Kilo means 10 to the 3. So 1 kilogram is equal to 1 times 10 to the 3rd grams. Sometimes I work forward, sometimes I work backwards, sometimes I jump around, but just to make things interesting. I'm going backwards this time. Here's grams and cubic centimeters. You're not going to find that in a table or a conversion factor or anything. That is this density of the white gas. That is specific to this problem talking about white gas. So 0.710 grams per cubic centimeter. Centimeters cubed to milliliters is 1 to 1. And then milliliters to liters, I need to know what milli means. Milli means 10 to the minus 3. I've got milli on the top. I'm going to write what it means on the bottom, on the other side of the line. 1 milliliter is 1 times 10 to the minus third liters. .45 divided by 1, EE minus 3, times 1 divided by 1 times 0.710, divided by 1, EE3 equals 1.0295 kilograms. How many sig figs?
3.
3. So 1.03 kilograms. Is that a reasonable mass for a cylinder of gas that you're going to take backpacking? I don't know. Roughly how many pounds is a kilogram? 2. So this is 1.03 kilograms. It's in the ballpark of 2 pounds. Yeah, you can carry that in your backpack. Any questions? I don't want to do that one. I'm not going to talk about this either. Order of magnitude estimations. This is a great skill. It's not necessary. Those of you who would get this, you can get it by just reading it in the textbook. Those of you who wouldn't get it and need it explained, I could lecture on it for an hour and you still wouldn't like it. So I'm not going to do that. Skip over that. Some problems involve equations. You can't do everything with dimensional analysis, unfortunately. Here's an example. Find the radius of an aluminum cylinder that is 2.0 centimeters long and has a mass of 12.4 grams. And we're given the equation. Volume is pi r cubed times L, pi r squared times L. So because I thought ahead, we are also going to need the density of aluminum. And I don't want to have to go look it up later, so there it is. So we read the question, we pull the numbers out. 2.00 centimeters, 12.4 grams. That's all the numbers. Well, what are these numbers? It's asking us to find the radius. It's giving us an equation, so that's kind of a clue that maybe we're not going to be just converting units here. It says it's 2.00 centimeters long. That's probably the L in this equation, right? The length. And 12.4 grams, what's that? What's the mass? There's no mass in the equation. I'm trying to find R. I'm going to have to rearrange the equation. Not sure what to do with those numbers, so I'm just going to go ahead and rearrange the equation. Volume equals pi r squared times L. I want to get R by itself. So I'm going to divide this side by pi and by L, because pi over pi is 1 and L over L is 1. But I have to do the same thing to that side. Okay? So now I've got R squared is equal to the volume divided by pi times L. But I don't want R squared. I want R. So I need to take the square root of R squared, and I need to take the square root of this side as well. So I take the square root of that, and I take the square root of this. The square root of R squared is just R. So there's my equation. Because I'm looking for R, I have to rearrange the equation. It's easier before you stick the numbers in there. So what do I need? Well, pi, that's a button on your calculator, 3.14159, and just on with seemingly random digits forever. Don't use 3.14. Use the pi button. It'll give you a whole bunch of digits, and your answer will be better. What's L? Oh, I know what L is. I need volume. I've got mass. How can I get a volume from a mass? density. So this is aluminum. So I went and looked up the density of aluminum. I can use this to change my mass into a volume. So 12.4 grams, I'm writing with an eraser, you can't see that, can you? 12.4 grams. Do I multiply or divide? Don't think about that. What do the units do? What am I trying to find? Volume in cubic centimeters. So I'm going to multiply by cubic centimeters. I'm going to divide by grams so the units work out. I don't need any tricky ways to remember what to do with that silly equation. I let the units tell me what to do. So I'm going to put it in like this because grams will cancel, and then I'll be left with cubic centimeters. So it's 2.70 grams, so that goes down here, per 1 centimeter. .4 divided by 2.70. And my calculator's giving me a big old mess. 4.59. In looking at what I'm doing here, I have 3 significant figures and 3 significant figures. So this result has 3 significant figures, but I'm going to use this in an equation, so I don't want to round it off. So I'm going to write down the next 2 digits, 25, to avoid rounding errors. And there's my volume. So now, R equals the square root of 4.5925 with the 9 underlined. That reminds me that this number has 3 significant figures, and I'm going to divide by pi times the length, 2.00 centimeters. So calculators use different logic, and so some of these you do going forward and some you do going backward. On mine, I'm going to take the square root of 4.5925 divided by pi divided by 2 equals, and the radius is 0.85. How many sig figs is this going to have? 3. Yeah, I just underlined it while I said that. Right? You paying attention? And then what happens with the units? Well, here I've got centimeters cubed, and I'm dividing by centimeters. So what that does is it changes. I cross out one of those there. But this is still under the square root. So I'm taking the square root of centimeters squared, and so I end up with centimeters. That's very reassuring that I did the equation right when the units come out correctly. So my final answer is 0.855 centimeters.
For the 4.5925, we don't keep that then, right?
No. No. The only time you cube numbers is in a conversion factor relating to cubed units. Like here I've got a cubed unit. Here I've got a cubed unit and grams. That does not mean I'm going to cube the grams or cube any numbers in there. If I've got cubic centimeters to cubic inches, then I cube the numbers. Yeah, so there's got to be 2 exponents that are the same before you mess around with that. Any other questions? Oh, we're done.